Hey there, science fans! Welcome to another exciting journey into the world of technology and innovation. Have you ever wondered how computers see the world? It's a fascinating process that combines hardware and software in ways that mimic human vision. Just like our eyes capture light and send signals to our brains, computers use cameras and sophisticated algorithms to interpret visual information. These algorithms are designed to process and analyze images, breaking them down into data that machines can understand. This amazing field is called computer vision, and it's changing the way we live, work, and play. From enhancing our daily lives to transforming entire industries, the impact of computer vision is profound and far-reaching. Think about it. We humans take our vision for granted. We effortlessly recognize faces, read emotions, and navigate complex environments without a second thought. We can easily recognize faces, understand emotions, and navigate our surroundings. This natural ability is something that has taken millions of years to evolve. But for machines, this is a complex task. Teaching a computer to see and interpret the world as we do involves overcoming numerous challenges, from understanding context to recognizing subtle differences in images. Computer vision aims to bridge this gap by enabling computers to see and understand images and videos just like we do. This involves training machines with vast amounts of data and using advanced techniques like deep learning and neural networks. From self-driving cars that navigate busy streets to medical imaging that helps doctors diagnose diseases earlier, computer vision is revolutionizing various industries. It's making our lives safer, more efficient, and more connected. It's helping doctors diagnose diseases earlier, automating tasks in factories, and even letting us unlock our phones with our faces. The applications are endless and continue to grow as technology advances. So, buckle up as we journey into the exciting world of computer vision and explore how machines are learning to see the world around us. We'll dive into the latest advancements and discover how this technology is shaping our future. Get ready for some mind-blowing insights into this rapidly evolving field. Whether you're a tech enthusiast or just curious about the future, there's something here for everyone. Let's explore the incredible world of computer vision together. Now, let's dive into the nitty-gritty of how computers actually see images. Imagine a digital image as a mosaic made up of tiny squares called pixels. Each pixel represents a single point in the image and has a specific color and brightness. Computers represent these images as matrices, which are grids of numbers. Each number in the matrix corresponds to the color or intensity value of a specific pixel in the image. So, essentially, computers see images as giant grids of numbers. Don't worry, you don't need to be a math whiz to understand this. The key takeaway is that computers break down images into their fundamental building blocks, pixels, and represent them numerically. This numerical representation forms the basis for all computer vision algorithms. Think of it like this. Just as we read letters and words to understand text, computers analyze these pixel values and patterns to make sense of images. It's all about translating visual information into a language that computers can understand and process. Okay, so computers see images as grids of numbers. These grids are essentially matrices filled with pixel values, each representing a specific intensity or color. But how do they go from these raw numbers to actually understanding what's in the image? This transformation from raw data to meaningful information is a fascinating journey. This is where things get really interesting. Computer vision algorithms employ a variety of sophisticated techniques to make sense of these numbers. Computer vision algorithms use various techniques to extract meaningful features from these pixel values. These techniques are designed to identify and highlight the most important aspects of an image. These features could be edges, corners, textures, or even more complex shapes and patterns. Each of these elements provides crucial information about the structure and content of the image. It's like finding clues in a detective novel. Just as a detective pieces together clues to solve a mystery, computer vision algorithms piece together features to understand an image. One common technique is called edge detection. This method focuses on identifying the boundaries within an image. Just like our brains naturally focus on edges and boundaries to identify objects, computer vision algorithms can detect sharp changes in pixel values to outline the edges of objects in an image. This helps in distinguishing different objects and their shapes. Another important technique is feature extraction. This process is all about identifying and isolating specific characteristics within an image. This involves identifying specific patterns or characteristics within an image that are unique to certain objects or scenes. These patterns can be anything from the texture of a surface to the unique arrangement of features in a face. For example, a facial recognition algorithm might look for patterns in the arrangement of eyes, nose, and mouth to identify faces. By recognizing these patterns, the algorithm can accurately identify and differentiate between different faces. By extracting these features, computer vision algorithms can start to build a vocabulary of visual elements that they can use to understand and interpret images. This visual vocabulary is essential for the algorithm to make sense of what it sees. It's like teaching a child to recognize different shapes and colors before they can understand the bigger picture. Just as a child learns to identify basic shapes and colors before understanding complex scenes, computer vision algorithms build up their understanding step by step. Through continuous learning and feature extraction, these algorithms become more adept at recognizing and interpreting a wide variety of images. This process is fundamental to the development of advanced computer vision applications, from autonomous vehicles to medical imaging. So the next time you see a computer accurately identifying objects in a photo or video, remember the incredible journey of feature extraction that made it possible. Now that our computers have a basic understanding of shapes and patterns, they can begin to interpret the world around them in more complex ways. This foundational knowledge is crucial because it allows machines to start making sense of visual data in a structured manner. It's time to teach them how to recognize specific objects and scenes. This is where image recognition comes in, the process of training computers to identify and classify objects in images. By doing so, we enable machines to perform tasks that require visual understanding, such as identifying objects in a photograph or recognizing faces in a crowd. Think of it like teaching a child to recognize different animals. Just as a child learns through repeated exposure and reinforcement, machines learn through a similar process of training and feedback. You might show them pictures of cats, dogs, birds, and so on, each time telling them what the animal is. Over time, the child begins to understand the distinguishing features of each animal, such as the shape of a cat's ears or the beak of a bird. With enough repetition, the child learns to associate specific features with each animal and can eventually identify them on their own. Image recognition works similarly, but on a much larger scale and with far more data. We train computer vision algorithms on massive datasets of labeled images, teaching them to associate specific features with specific objects. These datasets can contain millions of images, each meticulously labeled to provide the algorithm with the information it needs to learn. These algorithms use statistical models and machine learning techniques to learn these associations and improve their accuracy over time. The more data they process, the better they become at recognizing patterns and making accurate predictions. For example, to train a self-driving car to recognize traffic lights, we need to ensure that the car can accurately interpret the signals in various conditions. We would feed it thousands of images of traffic lights, labeled as red, yellow, or green. These images would be taken from different angles, in different lighting conditions, and in various weather scenarios to ensure the algorithm can handle real-world variability. With enough data, the car's computer vision system can learn to accurately identify traffic lights in real time, even in challenging lighting conditions or from different angles. This capability is crucial for the safe operation of autonomous vehicles. The more data we feed these algorithms, the more robust and reliable they become. This continuous learning process allows them to adapt to new situations and improve their performance over time. The better they become at recognizing objects and understanding the context of images, the more applications we can develop. From medical imaging to security systems, the potential uses for advanced computer vision are vast and varied. By continually refining these algorithms, we move closer to a future where machines can see and understand the world as well as, if not better than, humans.
Thank you for watching. Join us for engaging topics, clear and concise explainers, and tutorials that will help you navigate the complexities of AI responsibly. We also believe in the power of community. Your questions, comments, and feedback are what make this journey exciting. So, don't hesitate to join the conversation and share your thoughts with us. Are you ready to embark on this journey towards a more ethical and responsible AI future? Hit that subscribe button and turn on notifications so you never miss an update. Together, let's shape the future of AI responsibly.